Let's turn to our next talk. This is HomeBot is Alive, and this is relevant to anybody that has a water heater, that enjoys hot water. It's also relevant to people that are trying to deal with home maintenance activities or anything else that might involve a little bit of a computational approach to life's physical systems. Jason Garbus is basically a software industry person, and we'll hear in this upcoming presentation more about how those skills were applied to a home problem that so many of us have had. Let's check out that presentation.
Hello, and welcome to HomeBot is Alive, part of HOPE 2020. In this session, I'm going to be talking about building a Wi-Fi enabled, cloud-based, tweeting and SMSing Arduino water leak detector. Despite the very long title and the fact that it sounds like an all singing, all dancing type of extravaganza, I want to stress that this really is a very basic do-it-yourself project story. I'm definitely a beginner at the electronic side of things, and I want to encourage everyone, despite your age, your experience level, to take on a project like this. I think it's entirely doable, and we're going to walk through this and break it down, and I think you'll see that it's probably something that you'll be able to do as well. I'm Jason Garbus. You see my Twitter handle there. A little bit about me. I have spent my career in the software industry for remarkably over 30 years in a number of technical roles, starting as a software engineer for a while, moving into technical consulting, and been running and doing product management for software vendors for about the last 20 years. Mostly focused on middleware and software development tools for the first part of my career, and about the last 10 years I've really switched over and focused on identity management and network security. Today, these days, I'm really focused on Zero Trust. I lead product management for a Zero Trust network security company called AppGate, and I also have a volunteer role where I'm co-chair of the Software-Defined Perimeter Working Group at the Cloud Security Alliance. My background, I did study computer science as an undergrad. That's certainly not a prerequisite for having a career or doing things like this. I also have an MBA, which has given me some really interesting business-centric perspective, and I really enjoyed that program. I am a CISSP. I'm also a published author, and in fact, I'm working on another book right now, which is one of the reasons I'm so busy. So let's talk about why I put together HomeBot. It all started with I had a water heater leak at my house, and I want to give a public service announcement, which is if you ever fill up a glass of water from your sink and it comes out a little bit rusty looking and it's not from the neighborhood, don't hesitate. Go have your water heater checked out and probably replaced. If you do what I did, which is to say, I'm busy, I'm going on vacation, I'll look at this in 3 or 4 weeks, then you're setting yourself up to have a water heater leak like we did. Now, fortunately, this wasn't too bad, and we were able to address it with a dehumidifier and some fans, and everything was good. Of course, we had to purchase a new water heater and get that installed. Part of the installation process was this thing called a flood stopper, and I'll explain what that is in a minute. And that was interesting, not great, certainly better than nothing, and I'll explain in a moment how that works. And that was really the catalyst for me wanting to build something. So flood stopper is this electronic and electromechanical component that has a water sensor. You can see part of it on the bottom of the flyer here. And when that senses water, the alarm goes off, and it also electronically closes the valve. You can see it in the upper right here, into the water heater. And most interestingly, this has a normally open output contact. You can see here. Well, that was really the catalyst for me thinking, I could do something really interesting by taking that and building some sort of home automation system around it, which is, of course, what I did. We also had an unrelated sump pump issue where our sump pump flap got twisted and the sump pump rose up too high. Our basement didn't get flooded, but it did get musty, and a little bit of moisture rose up through the concrete floor, and I wanted to address that too. And ultimately, this was a fun technical project. We have something that is interesting, challenging, and not really related to my day job. It was a welcome change of pace. So one of the first things, of course, to decide is, well, what platform do I build this on? And I did a little research and looked, of course, at, do I consider something like Raspberry Pi? Do I build it on Arduino? Something else entirely? And what I did was I went through and I said, okay, well, Raspberry Pis, they're interesting, they're full-featured, they're running Linux, and I said, well, I can handle that. I work with Linux on not a daily basis, but an almost daily basis. it's a full operating system. I'm comfortable with the command line. I've been doing that for many years, but it does have a lot of moving parts. And it really started to feel a little complicated and too much like some of the my day job, so to speak. So I looked at the Arduino and I said, well, this is simple, and simple is good. And in fact, I only have to write 2 functions, right? And of course, that's not really true, but it's not true in a good way, as we'll see. So if I think about the overall flow of the system, we have the flood stop sensor itself, and that of course has those normally open output contacts, and that feeds into the Arduino Wi-Fi board utilizing a very simple breadboard. You can see that's not actually the HomeBot itself. It's a similar looking stock photo there. And then from that, we are going to make calls up into AWS to various things to do various activities, which we'll talk about. And ultimately, we want to be able to push tweets out to notify the status and if the flood stopper indicates moisture on the floor, as well as SMS notifications, of course, to be proactive so that myself or my wife can go down and check things out in the basement. Okay, so let's talk about this step by step. And the first step is, of course, to learn about Arduino programming. Arduino, of course, is a terrifically functional, open source, and freely available hardware and software platform. It's accessible through arduino.cc. I mostly use the web editor for building, compiling, and deploying this, with one exception to that we'll talk about a little bit later. The Arduino programming model is very appealing because, in theory, there's only 2 functions. There's setup and there's a loop. And of course, that's not entirely true, and we'll talk about a little bit why and some of the other capabilities later. But for the most part, that of course is the basic structure to it. I got started with the starter kit. Great way for someone like myself who had never really done this kind of electronics programming before. Has a basic board, tutorial, parts, everything you need to occupy yourself for several weeks, if not longer. I, of course, wanted to eventually get to a Wi-Fi enabled bot. So I purchased this Wi-Fi enabled Arduino board. It's the same functions, basically the same platform as the board in the starter kit, but it includes Wi-Fi capabilities built in. This one, of course, was the MKR 1000. It was about $37 a few years ago. There are newer versions available right now. And that leads us to actually an interesting thing. This photo here, you can see it has what are called the headers installed. So pro tip number 1, save yourself a headache and buy the version that has the headers already installed. Really easy to work with, easy to plug into the breadboard, and very easy to plug in wires to do your testing. If you buy the version on the right, which I made the mistake of once, it's much harder to work with. And if you're terrible at soldering like I am, it's just a complete headache. So that's my first tip for you. You also see that it has on the lower left side a micro USB cable, which is how you connect it up to your PC or your Mac to program it. More on that a little bit later. So let's talk about the software platform. The Arduino boards are programmed in C, and I can handle this. I was a professional software engineer using C to build client server and network system in the 80s. I'm dating myself a little bit, but I did this and I can do it again. The Arduino IDE, the web IDE, is pretty darn nice. It has pretty standard capabilities for software engineering practices. So of course you can have multiple files like you can see in the tabs in the screenshot below. They've got a nice built-in secret tab where you can put passwords or API keys or things like that. And they have tons of embedded and freely available libraries, examples, and things like that. Lots of stuff to find, and most of it is pretty good quality. So that's a really good platform. Something that I was comfortable with, terrific set of tutorials, and a great way to get started. Okay, let's talk about step 2, which is actually building the circuit itself. This turned out to be a pretty basic circuit, as we'll walk through this step by step. This is my PowerPoint rendered schematic, a logical schematic of what the circuit looks like. We used a number of pins here. You can see A4 and 6, 7, 8, and A1 to actually control the logic from the software, which we'll look at in a few minutes. I had 3 LEDs that I created to indicate power, activity, and alarm. And of course, those are set in output mode using the pin mode output function there with a 220 ohm resistor. The way these are set up, of course, is the power is controlled by software from the numbered chip there, 6, 7, or 8, that goes into the LED, and of course it has to go out through a resistor down to ground. Pretty simple circuit, very basic, and the other two, were set up exactly the same way. I also put a temperature sensor on this just for kicks, which is a little bit flaky these days, and I have to look at why that is. Power goes into the temperature sensor. Obviously, the other leg goes out to ground, and then there's a third leg in the middle, which goes to a pin that we read the setting on between 0 and 255, and then we do some basic math on it to calculate what the ambient room temperature is. Again, pretty straightforward process here with pretty inexpensive sensor. And then finally, the flood stop circuits itself, which is the heart of what we're doing here. This goes out, of course, we run power through that circuit. It's normally open, so there's no voltage coming through from the flood stop circuit. And in order for the sensor pin, A4, to read low most of the time, what you do is you run it through a resistor down to the ground so that it doesn't get errant readings. When the flood stop circuit senses water, of course, that circuit goes from open to closed, voltage goes through, and then pin A4 will read high and be able to respond accordingly in our software. So that's the basic circuit. Pretty straightforward. This is really the most complicated electronic component that I had ever built, which is not saying much, but it was a really good process for me to learn how this works and to build something like that. Okay, now we're on to step 3, where we actually look at the Arduino code. I'm presenting a slightly simplified version for clarity. I've removed some conditional compilation and some error checking just to make it a little easier for you to be able to understand this. There's one of the main functions is post message to HomeBot, and this is what actually makes an HTTPS post up to AWS Lambda with a simple JSON formatted payload of data. So we'll kind of build up to that as we go through the code. The heart of it, of course, is this loop function, and there's a number of elements to it. When it starts up, it does a post info message to indicate to the to the world that it's online and live and can connect to the network. And then there's some things that happen periodically. Every hour, it checks the temperature just for kicks. Every 3 hours, it'll post that up to AWS. Of course, if the water sensor is wet, every 60 seconds it's checking. If water is detected, it'll immediately post an alert message, and we'll see what happens up on the AWS side as a result of that. Likewise, if it senses a significant change in temperature, it'll also post an alert message. And then if it's time for the daily summary that happens once every 24 hours, then it will post a summary message. So that's kind of the basic structure. Let's go ahead and switch over to the Arduino IDE, and we can actually look at this. So here's a nice web-based IDE. And you can see we've got some constants defined in terms of the numbers of the pins for the power, ops, and alarm LED, as well as the input pins for the water sensor and temperature voltage. There's a bunch of stuff in here that I'm not going to talk about in detail around time and keeping track of time and keeping track of temperature. The time is interesting. I'll talk about that when we get to the following slide. But first I want to talk about the structure here. We've got some timing constants that are defined in terms of sample delay. This is set up to every 60 seconds. And then some things to indicate to it how frequently to tweet, some parameters around how long to wait for network connection and things like that. Let's go ahead and dive into the setup. So the setup is very straightforward. We configure the pins that we need, for some of which are used for output, some of which are used for input. We flash the LEDs just so that when you're there and you're looking at this thing and you first plug it in or debugging, you can see that it's on. We initialize a bunch of things in terms of counters and trackers and things like that, and then we exit the setup. That's pretty straightforward. The loop has a number of components to it. So the first is, I mentioned, if this is the one-time startup, then go ahead and post the info message. And one of the reasons, of course, is to get some reassurance that HomeBot is up, it's connected to the network, the Wi-Fi network, but also it allows the system to get the current date and time, and that's driven by actually the networking stack. It gets it from a network time server because the Arduino chip itself, the board, has no long-term battery and has no notion of keeping track of time, so we get that from a network server. Then we check the temperature here, and we keep track of, is it time to record our hourly temperature? If so, we'll put it in the array. And if it's time to post the temperature, then go ahead and call this post temperature log message function, which we'll talk about below. Next, we check the water sensor, and if in fact the water sensor is non-zero, then we have a leak of some sort. So we go ahead and we post an alert message and keep track of things there. We do have a counter in there so that we don't continue alerting. We max it out at 3 so that I don't get more than 3 text messages, because that would just be annoying. And then this is some just administrative things to keep track of. Hey, have I sent my daily summary yet? Have I passed the time threshold? If so, I'm going to start to format this message and go ahead and do this post info message. So if I scroll on down to really the post message format, I created this this simple structure where I'm sending in a message, which is one of these verbs here, up to the Lambda function, and then in the message, of course, depending on what the verb is here, there's actually different variables. Sump sensor, utility room sensor, whether this is an info message, whether it should send out a text message, etc. These are not very interesting, these post-info message, post-status message functions, because they're really just string processing and putting in horrendously escaped tag key value pair formats. Ultimately, these things go down to and map to the post message to HomeBot function, which takes that horrendously formatted message body, connects to the network, and then ultimately uses this networking function connect SSL to connect up to the API gateway in AWS with. Obviously, I've replaced the real gateway name here. You can see it's just an HTTP post. It adds in the message content, and then that's it. And it gets handled by the API function. And then we just look here for what the return value is to make sure that it comes back as it should with the 200. That really is the core of the Arduino functions in HomeBot. The other things here are pretty straightforward. Most of this, like the network functions, are from some libraries, sample libraries in Arduino that I've used. And then the temperature and time functions are pretty straightforward. So if we think about what we learned from this, I mentioned that the Arduino needs to get time from some sort of network time service. And that's built into the network stack. And if you try to access time and figure out what it is, before that's happened, of course, it'll come back as 0. UTC is definitely the way to go. The Arduino has no notion of time zones or leap hours, leap days, leap years, those types of things. So everything is much simpler if you just log it and keep track of it as UTC. HTTPS connection, of course, is secured with TLS. And in order to do that, the network stack needs to have a root of trust. That is, it needs to have a certificate issued by a trusted, the certificate that it's connecting to, which in this case is running in AWS, it needs to be issued by a certificate authority that is trusted by the board. So the way to do that is you have to run this firmware updater to actually take the certificate from just the AWS website there and actually save it into the firmware on the board. Otherwise, the network stack will not be able to create an HTTPS connection because it doesn't have a level of trust with the server. And when you do that, you actually have to use the Arduino IDE app, the program. The browser-based version doesn't have the capability to do the actual firmware update on the board. So that's something I learned. And the way you do that is you run this app here. You can see it's called the firmware updater. It's part of the platform. And there's an element to this simple UI that lets you can see at the bottom, upload a certificate to the Wi-Fi module. So that's the process for doing it. One of the things, however, is that I mentioned you can't use the browser version. So I actually ended up using a different computer for this. And when I use a different computer, of course, that's one thing that changed. I also happen to use a different cable. And one of the interesting things about these micro USB cables, pro tip number 2, is that many of them, most of them, are providing both data and power. But some of them only provide power, they don't provide data. And if you grab the wrong one inadvertently because they all look the same or you don't think there's a difference, and at the same time you've switched to a different computer and you're trying to use a different IDE, you will drive yourself crazy and beat your head against the wall because you don't understand why this thing isn't connected. So even though these things look exactly the same, just make sure that you use a cable that is providing both data and power connections and not just power. So pro tip number 2. Okay, the networking code is actually pretty straightforward, really very easy to work with. The formatting the data can actually be a headache for the posts. And one of the things I learned is that I was using a free tool called Postman to do some testing against the AWS side of things. And things were working fine through Postman, but they weren't working fine when I was sent the data up from the Arduino component. And there's actually some subtle differences in the way those two different tools formatted the data as it came through, and that was a headache to debug. So make sure you look carefully at that. Now we're at step 4, where we look at the code that actually runs inside of AWS. Now, of course, we have the Arduino, that's Wi-Fi enabled, and that's making network calls, it's doing something. Now, one option I thought about originally was to actually have the Arduino itself directly make the tweets and to directly SMS from the Arduino board itself. Now, that's possible. It's difficult. There's a lot more code that's required to connect up with Twitter, and there's some services you might have to use, SMSing. I looked at that. That's a little bit more complicated, and I decided let's just do this inside of AWS because there's a very rich platform there to do these kinds of things. So the way that works is essentially I want to have Arduino call what's called a Lambda function inside of AWS. It's just one Java class that you'll see. And in order to do that, what you do is you set up what's called an API gateway in AWS. And you set up a basic flow for the API gateway to call to the Lambda function. And then the Lambda function in my code actually calls out to use what's called the Amazon Simple Notification Service, or SNS, which is used to send SMSs. I store some data in the DynamoDB, and I make API calls that you'll see to tweet out some updates. So pretty simple, HTTP post into the API gateway. Pretty fun and easy to create this message protocol. And I talked a minute ago about Postman and some of the challenges there that in some cases can get you wrapped around the axle in terms of very subtle payload formatting. This is a screenshot of the AWS API gateway. You can see it's a simple post for HomeBot, and it's got a unique ARN there that is a unique URL essentially that HomeBot is going to call with the method request here at the top. Then it calls a Lambda function. You can see it's mapped to this Lambda function called HomeBot on the right-hand side, and then it simply sends an HTTP 200 status, which means everything's good with an empty body back because there's nothing that we want to send back. So that's pretty straightforward. The Lambda function itself, you can see, very straightforward as well. I chose to implement everything inside code, inside the Lambda function. AWS has some capabilities too. You can see on the right-hand side there, add a destination, and you can basically glue together output from the Lambda function. I chose to do it inside the code itself. And you can see here, it's a Java function with one function called handle request that's inside my HomeBot message handler class. And you can see that I've allocated a whopping 384 megabytes of memory associated with this. Because we love dependencies, right? When I first looked at the Lambda function, Lambda is a very capable platform, of course, and they support a ton of different languages. You can see there that you can develop your Lambda functions in. So I looked at this and I thought, well, maybe I'll start and I'll use Go. And Go, ultimately I said it's a no-go because I don't know Go. That was a little pun there. But it ended up being dependency hell because you can't just write a function to do something, right? You're going to end up pulling in XML parsers and other libraries and things like that. And I'd never used Go before. And I had also, I didn't want to have a learning curve of dealing with that at the same time I'm dealing with an unknown platform, because then I'm trying to learn and find my way in a dark cave, without a map. Whereas switching over to Java, I can certainly do Java. I was a software engineer building Java programs in the 90s. And I used the IntelliJ IDEA CE Community Edition, the free version, really powerful IDE. It wasn't dependency or packaging hell, it was packaging heck. So that was relatively easy to overcome. And AWS is a terrific platform. Their Java APIs are well documented, really straightforward and easy to work with. So if we look at the code for here, I mentioned there's one class called HomeBot Message Handler, and there's really just one function that I had to write. But there's lots and lots of packages, and you can see here I had to pull in AWS Java packages, XML processing packages, There's some Twitter packages, things like that. Nothing crazy, but it did end up being a little bit of a trial and error to pull in and find the right packages to get things so that the Lambda function was able to resolve all of its dependencies. So I probably could clean this up and make it a little bit more efficient, but I haven't had time to do that. Now let's take a look at the actual Java code that implements the Lambda function. Switching over to the Java IDE, you can see we've got the code exists in a package called HomeBot. I've got some documentation to keep my head straight here that explains what the message format is that comes across the wire, and this will match up with the information that's sent over from the Arduino code that we looked at a few minutes ago. At the top, of course, are the requisite set of imports in order to resolve all the dependencies. And then here in the class, HomeBot message handler, there's really just one function of importance called handle request, and that takes the input stream that's sent to it and provides an output stream to be able to publish results. So we create this thing called a buffered reader that takes and processes the input stream. And then what we're doing is we're basically parsing that reader into this JSON object. And then we can start to pull out key value pairs. First thing we do, of course, is we look at what's the message type here. And then if it's a status message, I'll do certain things. If it's an alert message, I'll do certain things, et cetera. Ultimately, if it's a status message, for example, we know to look for the sensor status because that's what's going to be sent with it. And then we pull that out, determine if it's dry or wet, and then we'll actually tweet out the results because that's what we're supposed to do as part of a status message. Likewise, on an alert message, we'll get the information out. In addition to tweeting out, we're going to publish the SMS message to alert myself that, hey, there's a problem, you better go take a look at it. Then there's the information message, which we use to tweet out as well. And then there's a couple other things, a temperature log message and a test message, which I used for debugging purposes. And then, of course, there's the unknown message, which actually tweets out saying, hey, something's up. I've gotten something unexpected. You need to check out what's going on. Pretty straightforward there. Now, if we look at the actual, I'm going to scroll down, code that does the external communication, publish SMS message here, you can see we are using this function called Amazon SNS client, and that's what is used to push this out. And you can see you put in a phone number. That's obviously not my real phone number. But you tell her that, hey, this is an SMS message, type promotional, go ahead and send this out and publish it. As long as you stay within the rate limits that are imposed by AWS, this is free, and the rate limits are extraordinarily high for something like this. So there's no danger of hitting any rate limits with this. The second external communications function is tweet out, which is really, really simple because I'm using this library called Twitter Factory. What you do is you provide it with some OAuth authentication tokens, essentially. You can see some placeholders there. You obtain those by registering as a developer or a bot on the Twitter website. Once you have those, you can then use them you can see with the very few lines of code, just go ahead and do what's called an update status, which means tweet, essentially, and send that out. Again, very straightforward, much, much easier than going against the raw Twitter API, which is pretty complicated. The rest of this is basically parsing and managing data. This is one additional thing, which is where I put in some code to persist this to Amazon's built-in DynamoDB. And here, this is, again, really straightforward. I simply take this Amazon DynamoDB object, instantiate it, and then you're basically putting in key value pairs into that periodically. So some notes on this. I mentioned I use this Twitter4J library, and you can see the URL up there. Really, really easy, and I recommend, again, using that then rather than trying to work directly against the Twitter API. Publish SMS message, really simple. Amazon has that built in, likewise for DynamoDB. So terrific platform, very easy to work with, and once I got through the dependency hack, this was actually pretty straightforward. So if we think about now, what does this look like? Well, of course, HomeBot is alive and active on Twitter under the handle at 7B-HomeBot. You can see there. And he's made, or it has made, you can see over 6,700 tweets over the past few years, and sends out daily updates around 1700 UTC. You can see that right here in the middle. as well as updates every 6 hours from both the sump pump bot and the utility room bot. The SMSs that come through, you can see a screenshot from my phone here. They come through, again, once a day, basically saying, hey, I'm alive and well. This is my max and min temperature from the utility room. And as I mentioned earlier, that data is definitely not right. My utility room is not 115 degrees, probably closer to 80. So I definitely need to look at that and understand if there's a loose wire or if I need to replace the temperature sensor components. Okay, and now it's time for the video demo of HomeBot itself in action. So let's take a look.
Hello, and welcome to the utility room in my house, place where the HomeBot lives. You can see it's a small interior room in my home. We have a gas-powered, forced hot air heating system, and we have in here, of course, the electrical box. We have the hot water heater. This is the new hot water heater. You can see it's from November 2017, replacement for the one that leaked. And you can see over here the flood stop system and HomeBot itself, and we'll talk about that in a minute. The flood stop system, you can see, is mounted on the wall. It's a very simple circuit board. And down here on the floor, we have the actual water sensor. A very simple circuit that is running probably a couple of volts through here with wires that are exposed. And when we drop a drop of water on it in a few minutes, then we'll see an alarm. The flood stop sensor is also connected to the hot water heater. You can see there's an electronically controlled valve here to the input. And when the alarm goes off, it will actually close the valve to prevent unlimited water from flowing through. Obviously, we've got a water tank full of hot water, so if it leaks, all of this will come out. So we wanted to put in a better way of doing this. Here's the HomeBot itself, and you can see it's held up with painter's tape, but it does work. And it's hooked up to the output, to the ports on the flood stop, and you can see that it's running voltage through that, and if it's flood stop senses water and it closes, then it'll actually go off. And you can see we have some basic LEDs, and we have the temperature sensor as well. So now we're actually going to give a demo, and I'm going to take some water, put a drop of water on the sensor. What will happen is a number of things will happen at once. First of all, the flood stop will make an annoying alarm. Second, the valve on the flood stop will close up here, and you might hear that. And then the HomeBot itself will go into alarm mode, and it'll send out a tweet, which we'll see as well. So let's watch this in action. Here we go. Now he's unhappy, clearly. We're going to silence that. And you might have heard the little valve here closing. And HomeBot itself is on a 60-second cycle. So sometime in the next 55 seconds, we should see it wake up, and the red light will go off, and indicating that the water sensor is wet. And then it will actually go through the process of sending out a tweet and an SMS message, which we'll be able to look at as well. We didn't actually catch the red LED on video, but we do have a screen recording of the text message coming in here. And there we go. We're here in the storage room part of the house by the sump pump, and you can see sump pump bot is right here next to it. Very similar circuit, very similar setup. In this case, we have a water sensor that's dangling down about 8 inches or so into the sump pump area. It's the middle of summer, so the water level is quite low here. In the springtime, late winter and springtime, this does tend to run fairly frequently. And on the off chance that the flap gets caught again, the water level will rise up, the sensor will get wet, and the utility bot room, the sump pump bot will alert. So we shall demonstrate the sump pump bot. I've taken the water sensor out to make it easier to pour a drop of water on here, and we'll see what happens. Pour a little water on, you can see immediately that the red light goes on, indicating something's happening. And in a moment or two, what will happen is the sump pump bot will wake up from its cycle. The yellow light will flash, indicating that it's active, and the red light should flash, indicating that it is actually in alert mode, and it will send out an SMS message as well as a tweet indicating this. Yellow light has gone on. It's trying to connect to the network right now, I believe. That's what it's doing. To get the time. And then what it's doing is the red light goes on, indicating that's in alert mode, and it is sending out an SMS message that should show up momentarily, as well as a tweet.
As we saw in the video demo, HomeBot will tweet out alerts when the water sensor detects water. And you can see that here, the sump pump and the utility room from earlier today. Likewise, the SMS messages come through on the phone indicating that there's an alert and some action needs to be taken. So now we closed the loop here all the way from looking at the actual hardware, the water sensor, the code that runs, the flow through AWS, and the actual output here into Twitter and an SMS notification. So let's wrap up. We currently have 2 bots that are running, the utility room bot that we saw in the first part of the video demo, and there's definitely something that's not quite right with the temperature sensor, so that's on my to-do list. And then the sump pump bot, which is the second part of the video demo. Aside from the temperature sensor thing, this is pretty reliable in terms of the Arduino hardware, the infrastructure that I'm using. I don't have to really monitor these things. They run month after month after month without any issue, and we get my daily text messages, we get the tweets. So I've been really pleased with that. There's no memory leaks or crashes or anything like that. So that was pretty fun, and I was pretty pleased with the output there. So what's next? Well, I am pretty busy these days, so I don't know that I'm going to have time or make time right now to do anything further on HomeBot, maybe perhaps beyond fixing that finicky temperature sensor. There is the potential for another bot called ToiletBot. We have one problematic toilet in the house. We've replaced the valve system a couple of times. It still runs once in a while. So my thought process was to utilize this inexpensive water flow meter component that I purchased. And essentially, you hook this up to your Arduino, and using Arduino interrupts, which is an entirely different way of programming it beyond setup and loop, this will basically send pulses into the Arduino board, and it can calculate how much water is flowing every second. And obviously, if the toilet is quiescent, nothing's happening, there's no pulses. If there's water running to refill the toilet, then obviously there'll be a certain number of pulses per second. So it would be very easy to put together a system that detected how long this toilet was running for, and if it exceeded the 45 or 60 seconds that was typical, then it could send an alert. The challenges around this are, well, there's some basic plumbing involved, but I can handle that. It's going to be some plastic coupling and things like that. But more challenging is that there's no power that's immediately adjacent to the toilet. So I'd either have to run an extension cord up and around the vanity, which would be pretty unattractive, or drill into the bottom of the new vanity. That could be problematic as well. So that's not on the horizon right now, but it is technically doable and could be an interesting project. Of course, these things are available online for purchase because everything is, and clearly there are relatively inexpensive components that I simply could have purchased to do something pretty similar, from a Wi-Fi enabled water meter to a sump pump monitor. But ultimately, that wouldn't have been as much fun. I've learned a ton here. I really enjoyed the whole process of discovery, exploration, making mistakes and learning and putting all this together. And I'm pretty proud of this. As crude and basic and ugly as this thing is, it's really neat to have it in your house and know that this is something that you built and wired together. So ultimately, this is fun. It was a very different kind of technical challenge than I face on a daily basis, and I would encourage folks to do that. The set of electronics and the types of components that are available today are really mind-blowing. You can just put together incredible things for very small investments of money and a modest investment of time. Sometimes security around this, like the HTTPS certificate and getting the figuring out how to make tweets, is the hardest part, and that's okay. I work in the security business on a daily basis, and I understand the need for it, and this actually reinforces the need for us in the security world to try to make things easier, simpler, and more transparent for folks who are just trying to get their job done or do something fun like this. Don't be afraid to question the tools that you're using. Sometimes your tools are imperfect. And of course, as always, the internet is an incredible source of information, technical information, guidance, opinions. Sometimes it's even right. Sometimes it's the right answer for you. Sometimes it's not. So just take that also with a grain of salt. And you may not find an actual recipe for the exact steps you're doing. And that was certainly the case here. There were bits and pieces and examples and demos that I pulled from to help me learn how to solve one problem at a time. And there were some examples online that were fairly close, but there was nothing that was exactly this thing sewn together. And that was kind of the fun bit, right? Is figuring out how do I do this in a way that, where you're creating your own path. So I want to certainly thank you for attending. I hope this was a useful and interesting session. And I want to thank Hope and the organizers of this conference. I know it was a big shift to do this online, and really pleased and thrilled to be one of the presenters and to participate this year. And I certainly hope that we all stay healthy and stay well and can be together in person next year. So, and thank you. This is going to be ending the recorded part of this, and I'll be available live for Q&A.
How many of us have had problems like that and called a plumber, went to the hardware store and tried to find a sensor, and just didn't figure out all those problems? That was an inspiring talk about how you approach this common sort of problem that had, I think in your case, a somewhat uncommon solution. Jason, welcome to Hope, and maybe you could just start out by telling me how you would recommend that people get started as a beginner, because this is what the journey that you went on, and what sort of mindset you need to take.
Thanks, Greg, and thanks to you and all the organizers of Hope for having the opportunity, and doing this virtually. I think has worked out really well, and I think is a great accommodation for the state that we're in. I definitely have a growth mindset in general. Consider myself a lifelong learner, and I'm not embarrassed to try something new and be a beginner at whatever it is, whether it's intellectual or physical activity. And I did call a plumber, trust me. We had to bring in the professionals to change out the water heater. But I saw that component on the flood stopper, and I thought, well, wait a minute, I can do something interesting with this. And I really want to be alerted if I'm out of the house or out and about if something's gone wrong. And this kind of opened up this whole world to me of home automation and the way that you can build on these platforms and do things kind of that moves away from the pure software world into the physical world. And I think I would encourage everyone to try this. It's, even though this is a very basic project, and it's, I think it's well within the range and the capability of a huge number of people, whether you're a beginner, whether you're a teenager or even younger than that, or whether you're someone more advanced in years like me and you have different skills and you want to try to learn something new. So I really think that too often people have a closed mindset. They're not open to trying new things and learning new things. I want to encourage people to try to approach things differently.
Oh yeah, that's what Hope is all about. So absolutely relevant. We had a few questions about some of the details. One of them was essentially about the choice of more industrial parts versus like more hobbyist parts, or sort of the cheapest parts you can find. And what did you dig into choices of components?
You can see clearly that it's held together with painter's tape and using breadboard. So clearly this is hobbyist parts. And I think if I were to want to take it to the next level, then yeah, I would probably work with someone who has more experience than me in building circuits, soldering, and putting together something that's a little bit more, I wouldn't even say professionally packaged, but a little bit more resilient packaging. So I didn't explore that because I was really interested in the process of getting it working and seeing how this thing worked to end, and that's kind of where I stopped on that journey.
Mm-hmm. Neat. Someone was watching your video very closely, and they wondered whether you had broken a bit when you were installing the anchors, because I think they noticed some of the anchors and also a hole behind the taped up Arduino plate. I think it was just curiosity about the difficulty of drilling into that concrete.
Oh, down where the water sensor is. So, well, the water sensor is just on the floor. It's underneath that PVC pipe that's holding it in place. So I didn't drill into that. And then there's a drain there that is completely separate system. That's just the outflow from the condensation from the water heater.
Having the late morning howl here, I'm going to type my next question.
You're muted, Greg.
I put my question into the text. I'm having a dog howl festival here.
No problem.
I'll cover for you, Greg.
Okay. There are building automation systems and standards. Are those necessary or relevant or good building blocks? So, I mean, clearly this is a pretty basic hobbyist style project. This is using, 5 volts that go through the board. So this wasn't something that required either complying with standards or a permit or anything like that. Clearly, if you're working with something more substantial, if you're trying to interface with 120 volts, you got to know what you're doing, which I do not. I wouldn't, build something that uses that type of voltage or ties into something that could be dangerous in any way. So definitely know your limits and be careful not to cross that line.
Somebody had a question of, have you looked into making PCBs? It's pretty cheap and easy to get one made and solder a couple of resistors.
I haven't looked into that. I think that's a really interesting idea for a potential next step here. And, it would be interesting to look at, what other platforms there are to kind of have people even use some software like this, even in some future state, I could open source some of this so that people could leverage it for, even more accelerated mechanisms or ways to do this on their own. I'd be happy to share that with people.
I'll let you take over, Greg.
Yeah, thanks for being a ringer there for us. I don't know if people know I have a bunch of dogs in the house, and so far this is the first time they elected to howl right when I was in the middle of speaking. So I apologize for that. It's just a thing they do. So there was also a question about the sensors. The question was, why did you not set up the sensors to trigger interrupts on those first 2 HomeBots?
I suppose I could have done that. It's just a plain circuit that is either open or closed. So I wasn't sure if you could hook it up to an interrupt or not.
Mm-hmm. Yeah, so that sounds like a real learning process. So yeah, this was inspirational, and I apologize, I might have missed it in the talk. Did you put, is there an online resource with any of these photos or,
No, I've not.
Anything like that?
Not had a chance to put that together.
I haven't got to that level yet, but obviously the talk here will be on replay, and people can watch that, and I think they can get in touch via the program if they want to follow up with you. So, well, thanks so much for sharing this. Is there anything else you want to mention in closing?
I want to thank you, and I do want to encourage folks to take a growth mindset and really look at things that you can learn and try new things out. And I think that's a pathway toward lifelong intellectual engagement and fun and just ability to grow. So thank you.
And once again, that's what HOPE is all about. So this has been Jason Garbus talking about HomeBot. It's alive. It's still alive, right?
It's still alive.
We can still use, okay, I just want to make sure it was still an accurate title. And this is Wi-Fi enabled cloud-based tweeting and SMSing Arduino water leak detector, a basic DIY project story. Thanks for being with us, Jason, and enjoy the rest of HOPE.
Thank you.